Okay, dann ist auch svona, og svo svona, og halló. Okay, ég held að við séum nokkuð með ready to rumble. Alright, so this will be in English, as in always. I mistakenly spoke Icelandic before because the course is supposed to be in English, so I'm sorry. But okay, problem set 7. Okay, so basically what we're going to do today is we're going to look into Scheme, a programming language that mimics lambda calculus, just directly, almost. So you'll now be like getting your fingers dirty in functional programming. Okay, well, shall we just get right in? And yeah, this is this lab class will be like, we're gonna do some programming together, and I hope that you, on your computer, do it before I do it, so you can just learn from doing, and of course seeing. Okay, so so basically, Scheme has it's just like a lambda calculus, but sorry, I'm opening the live chat so I can see if someone types to me. Okay, sorry. Okay. So Scheme will have a lot of braces. Like you will have braces everywhere, and it's the same setup for Scheme as in lambda calculus. That the leftmost element of a brace, for example, yes. Link is not on Gata. It's not on Gata. Is this not working? Oh, yes. Wait. Like so. Yeah. Sorry, I paused the new one. Sorry. Yeah. So the reason I paused the new one is because the attendance of the previous 2 lectures have only been like 2 in total people showing up because of a really huge assignment in another course due tomorrow. Okay. Alright, so let's get back to this. Okay, so write the following scheme ladder expression as a lambda expression and simplify the equation on it. So okay, Scheme has like any other programming language has some inbuilt functions, and one of those functions is let. And as you can see, this is a structure similar to lambda calculus. You have braces surrounding the elements, and you see that the plus is a prefix. It's like, you can see it here, like it's a plus xy, meaning that you plus these things together. But okay, so first thing that comes to mind is like, what does this let expression mean? Like, what does it do? Well, it just says let x be 3 and let y be 4. And in the following, it says, well, okay, since I've already declared that x will be 3 and y will be 4, just add those numbers together. Right? Does that make sense? That's basically saying, I'm stating that x will be 3, y will be 4, and here's an expression that says plus xy. Okay, so after knowing that, do you think you can build a Scheme function? No, a lambda function? Lambda, oh no, it's all here. Okay, let's just build a new one. Do another one. So, okay, let's encode this as a small scheme here. Okay, so we are supposed to take this sentence, or this statement, and create a scheme, lambda calculus for it. Okay, bam. I'm gonna make this a little bit bigger. Alright, so since you know that the elected expression is just applying 3 into x and 4 into y, how would you structure your lambda calculus? Remember for last lecture, lab class, we were doing like lambda. I'm gonna steal my lambda from here. So here you go. So I have like lambda x, then I would, for example, say plus x3. This would be something that I could calculate if I put something out of around it. So like now I'm applying 5 into x. Do you remember from last Labclass? Like we would take this expression and just do something with it, like take the 5 and apply it into the x. So basically every time you see an x in the expression, you just replace it by a 5. Remember? Yeah? Okay? So basically we're supposed to build some kind of expression using lambda calculus to mimic this scheme function. So basically we have an x, we have an y, and we have to add them together. So we know for a fact that somewhere we're going to have x, y, this thing, right? Okay, but now we have to structure the parameters into it, right? Basically we have to say, well, we have lambda x, and we have lambda, oh my god, okay. Lambda y. Bam, bam, bam. See? Does this make sense? That's the core of the function. It takes in 2 parameters, x and y, and adds them together. Now the only thing we need to do is just apply the values, right? We have already, this expression tells us that 3 will go into the x and 4 will go into the y. So how do we do this in the calculus? Do you remember?
So
And the third, yep.
there's
So after the third, like here or here. So
one
more, you would say a 3 here. Okay? And then where would you put the 4?
between the two last one.
Between the 2 last one. Okay, that's totally correct. Because now what you're saying is I'm gonna apply 3 into this thing, and instantly this thing is an x. So you replace 3, like replace x, replace 3 with an x. Oh, x with a 3, all the way around. Sorry. So basically you would take this and copy paste it into the x here. So this is totally right. So let's do that. Let's try to simplify it. We have all the parameters, we have everything we need. So let's try to simplify it using the approach we used like last time. By taking each parentheses and looking at, yeah, this lambda is x, and we're applying 3 into x. Therefore, I'm gonna take 3, put it where x is, and remove this lambda. There you go. So this is the first step. What's the second step?
4 into y.
4 into y, of course. Knock down this parentheses, replace y with 4, and remove the lambda. Okay. And now there's one step more, that's just the cleaning step, removing all unnecessary parentheses, and then, what's this? 3 plus 4, 7. Trick question. Alright, 7. So yeah, that's basically the first tasks that we're supposed to do. Basically, write the scheme, write the following scheme expression as a lambda expression. Well, we did that. This is it. And simplify the expression on this. So here we go. This is just how you would write this lat expression in lambda calculus. Does this make sense? Can this? Can you see the mapping between?
Yeah.
Totally. Okay, good. Okay, so let's dip a little deeper into scheme. So the next assignment is, or the next thing we're supposed to do, I'm going to zoom a bit out. Can I zoom a bit out? Here we go. The next thing we're supposed to do is write a scheme function count. It accepts a list as a parameter and returns the number of elements in that list. So we're gonna iterate over a list. Before we get started, scheme has some built-in functions that you can use to manipulate lists. First of all, if you have a list in Scheme, well, let's say we can declare a list like so. A, B, C. So this is like a list with the elements A, B, C in it. I note that you put this thing, what's it called? Gazella. I don't know what's called. Quotations? Single quotes. Single quotes. You put a single quote in front of the list to declare that's an actual list, not a function call. If you did this, then he would think that A is a function and I'm going to call A with B and C. You don't want that. You want to declare a list and therefore you put a single quote in front of it. Okay. That's just one of the things that you need to know, is that you can put a single quote really in front of anything. If you put a single quote for something that is literal 1 or 0 or something. Okay. So the second thing is, okay, let's say I have this list in my hands and I have it in some kind of variable. Let's say I have it in this variable. I have access to a variable that contains a list. Well, what I can do then is I can call, if I want the first element of the list, let's say I just want the A from this list, then I can call car, which is the first thing, like it's a head. Okay, you can say car of list, and this will give you basically A. Okay, this example. And CDR is the tail of the list, which basically means everything except the first element of the list, which would give you another list, basically a list containing B, C. Is that understandable? Like, R gives you the first element, CDR gives you everything else. Okay. And the reason why it's called car and CDR is because this is a really old programming language, and the designers that were creating it or using it actually decided just to call it the same name as the registers in the CPU. So every time they had a list in memory, well, car was the first element of it, and CDR was the pointer to the rest of the elements. So yeah, I agree. It's not good. It's not a good design decision to use just the registers. But okay, this is what we got. So with this new information in hand, we shall create this function. Okay. So before we we have to define some functions. So how we create functions in Scheme, we say define define, which basically says I'm going to define some function, or yeah, just function. Okay, and I'm going to call it. So basically, it's a define takes in 2 arguments. The first argument is the name of the function and the parameter list, and the second is just the body. If you think about it, it's just like the top line and then the block inside it. So I usually do something like this. So this is just like the name would be count, and it takes in a list. So this is just like the count takes in a list. Okay. So now we have declared the function. Maybe it's count. It takes in a list, but we haven't defined the body yet. So how do we actually count the elements onto the actual task? Okay. So we're asked to create a function, takes the list as a parameter, and returns the number of elements in the list. Now, the first thing that comes to mind is of course, well, we just do a for loop. We just loop over all the elements. Well, we don't have any for loops or while loops or loops at all in Scheme. We use recursion. Everything is recursion. You recurse over things, you recurse into things, like it's all recursion. So this is one of the big mindsets that you have to like adopt, like from the usual looping to, well, I can do this another way, I have to use recursion. So that's another thing that you have to like get your mind into, use recursion. And I think you all have all done recursion in like algorithms and data structures, I think. So you should be a bit familiar with it. But functional programming is all about recursion. So how do we do this? Okay, well, let's say if this is another expression in scheme, it basically says if something is if condition, if it's true, and if it's false. For example, if the list is null, then I'm gonna return 0, right? So if there's nothing in the list, well, then a count of the list is 0, right? Does that make sense? Okay. I might be going too fast here, but please slow me down if I'm going too fast. Okay, the first thing is just like we get the base case. If you remember from data structures or algorithms, in recursion you always check the base case. So basically you're checking, okay, I'm gonna count, and if the list I have in my hands is empty, I'm just gonna return 0. Well, if it's not empty, I have to do something else. What should I do? Count somehow. How would you count? Somehow. So one way, or I think the best way, is just saying, okay, 1 plus something. And here comes the recursion part. Well, I'm gonna plus 1 to something. Well, I can just call myself again on the list or on the rest of the list. Okay, that's it. We're saying 1 plus me again on the rest of the list, and I'm discarding this element. Does this make sense?
It's like popping the...
It's like popping. Yeah, you just advance over the element, add 1, and just ignore it, and continue until you hit the base case, which is basically an empty list, which you will always reach because you're just iterating over all of them, and then you say 0. So for example, let's just pick this list. And I'm gonna do a really simplified stack trace of it. So if I do a count on this guy, then the result of it would be 1 plus this guy, which would be the result of this, would be 1 plus this guy, which would be the result of 1 plus this guy. And oh, we just figured out that the base case is this guy, right? We got it. Like if the list is null, then we return 0, and therefore this becomes 0. And you just add together. See how it works? It just discards the first element and put a 1 plus to it. So this is how the recursion counts. It recursively calls itself on one less element and pluses 1 to the result. Right? You're following? Yes, maybe? Yes. Cool.
Does there not have to be a parenthesis around the 0?
Oh, where? Here?
Yeah.
Actually, you don't need it. Because he figures it out. That it's a 0, and like if it's 0 within parentheses, he thinks it is a function. So it's just like returning a 0. But okay, that's a good question though. Let's just jump into the tool that we can use to actually execute this thing. Go. Okay, so this is the racket, and I think I can maybe increase the font size a bit so you can actually see. And it's actually a tool that's available both for Windows, Mac, and Linux. And like, I encourage you to use this because the tutorials point isn't that good. On my website where we used Smalltalk, Scheme wasn't doing so well, like for me at least. So okay, so basically you have to select the language, which is just Racket, which is Scheme, just its own thing. Okay, so let's take this. What I'm gonna do is I'm gonna have this over here if I can. have this over here. Make this a little bit smaller. Is this still readable? I think so. I'm gonna hack a little bit for me on. Man, I think it's still readable. Yeah, it's still readable. Okay, cool. Okay, so let's take this function. Okay, so here we've declared the function inside this. I'm gonna press run, and it looks it up. So now I can actually say, hey, please, can you count for me this thing, A, B, C. And he says 3. Yay, we got something running. Okay, so, and it does it by this method. It 1 plus the result, 1 plus that, until you hit the base case where you say 0, and then it's just 1, 1, 1, 1 for every element. Right? Cool. Okay. Okay, so the next question is, here we go. Write a scheme function last, which accepts a list as a parameter and returns the list that the last element. You can assume that a list contains at least one element. Okay. So now we're supposed to a new function called last. Let's just start that here. Define, and remember that when you're defining a function, the first parameter is telling its name, so this will be last, and inside this would be the parameters. It's supposed to take in a list, okay, which we'll call just list. Okay. Okay, so my question is, well, now we have every tool that we can have. Like, okay, I'm gonna look at this code. So here we have an example of how to count lists. So we have some list manipulations here. So can we use any of them to actually, well, check the last element? So how would we actually go about getting the last element of a list? Hint, hint, recursion. So, the last element of a list is basically an element that has no tail. Does that give you a hint? Okay, what is the tail of the last element? Null, right? So we have something to check by, right? We have that if we have the last element, well, then the CDR, which is the tail, should be null. Does that make sense? Okay, well, we can just check that. We can say, well, if it's null, something, and we say CDR of this, well, if it's null, then we know that this is the last element. So we want to return what? Remember, we have these two fantastic operations, CDR and car. Yeah, return car of Liz. Basically, we want the first element, or we want the element itself. So we will return the first element of the single entry list. Cool. But if it's not, here comes the recursion part. If it's not the last element, what happens?
Just last.
So last and CDR of list. That's totally right. So there you have basically the recursion part, which is, oh, okay, this is not the last element, so I'll call myself again with the rest of the list. Not the, so you're skipping over one, you see it? Like, you're skipping the current element and just moving on to the tail, or the CDR of it. Okay. So let's see if this works. Okay. And I have to hit run, and let's see. Last A, B, C. And what should this return? C, right?
Yeah.
Last. C. Ooh. But it basically like iterates over the list until it finds an element which has no tail, i.e. the last element, and returns it. Cool. Well, okay. Well, the next thing we should do, number 4, is define a function makeList, which takes in a non-negative integer and an object O, and returns a new list with n elements, where each element is the object O. Okay, so before we actually start doing that, I'm gonna show you a function to actually create lists, because we'll definitely need that. So, okay. So this thing constructs a list. So for example, if I say, hey, take this A and put it into an empty list for me. And yeah, if you're gonna execute any function, you have to actually call it by putting it inside of parentheses. There you go. You put a into an empty list, which basically creates a list with just A. Okay, so for example, if I put this into a list with B and C already there, you get A, B, C. But append or like prepends, it inserts in the front. Okay, make sense? Like this is a tool, it's a handy tool that we should use in the next task. So we have this thing. So I'll just copy it here. Up. Okay, we should create the function. Oh, before I do that, let's say here we go. This would result in this thing A, B, C. So like we have this helper thing to help us create the list. Okay, let's go. We have to define this function, and we called it make list. I think it was actual make list. No, yep, make list. Okay, and we should take in an n, which defines how many elements, and we should take in an o, which defines what element we should repeat. Okay. Now, my question is, how do we do this? Like, what's the base case? What if n is 0? What happens then? So let's put it like so. If n is equal to 0, what happens? What should I return? Think about it. Make lists, and I want 0 elements in my list.
A new list.
It's like so. You just return empty list. Yeah. Basically, if you want 0 elements of a list, I'll just give you an empty list. Okay, cool. But what about if it isn't 0? Like, if we should create a list with some elements, we actually have to do some work. Like, not just return empty. Well, yes. But it's right now.
Ja, en ik heb echt een laten.
Ja.
Dus ik heb het helemaal.
Bra.
Als we doen spoelen aan de vingers. Oké, kijk.
Alright. Alright. Where were we? Yes, creating a list. So, okay, we have to do some work here. Basically, there's construction of something. Like we have to construct lists. And how do you do it? Well, this should be a good hint. Like, if we're going to repeat O, then we should just construct a list by saying O and something else. So what should we construct the list O against? Or am I doing this too fast? Okay. Before we go here, let's just think about it. We want a procedure similar to the pluses. Let's say I do this. So if I say cons of there's A, cons of B, cons of C, cons of empty, what do you think happens? So if I construct a list by always adding one element to the list, what happens? What do you think? You get the list with these elements, right? Oh, okay, let's look at it. So here we have cons. So this basically would show you that cons takes something and puts it into the list, in front of the list. So for example, if you say A and the list that contains B and C, you will get the list with A, B, C. So if I do something like cons of A, cons of B, and just like circle, I would get 3. Okay. So it's basically taking the first argument and put it in the first place in the second argument. So okay, like this is actually incorrect. It could be like this. But basically, we'll put a C into the empty, and then we'll put a B into a thing that resulted from putting a C into empty, basically C, and then we would put an A into the front of, so we get an APC. Okay, so let's just look at it. Like I'm going to construct a list that I'm going to put O in front of, and how I would get the list is just recursively call myself again, because I will return a list, right? So every time I call myself, I'm guaranteed to get a list back. So this is the recursion part. And here comes the tricky part, which is saying, well, I'm going to say n-1 for the n's and put a O back. So this is the function. Now let me describe it. It basically says, okay, if n is 0, then I just return you the empty list, because it's an element, there's no element in it. Okay. If it's 1, then I'll construct a list with an O followed by an empty list, right? If this is called with n-1, then it will be 0, so you would get the empty list. Okay, so basically it would be an O, it would be a const O to the empty. This would give us, right, O, like so. Okay, and here comes in the power of recursion that when you call yourself over and over and over, you just append, and how you count is just incrementing the n by 1 every time. Does this make sense? Yes. Maybe. Okay, so let's try that. Yeah, I have some errors. Control. Okay. Always the missing brackets. Here we go. So I have this function make list with, let's say, 3 and an A. So this will basically make a list with 3 A's, right? Oh, sorry. I accidentally put something. So there's an AA. A. So basically creates a list with 3 A's. Right? Okay. So what do you think if I put something like this in front of it? What does this do?
ABC, ABC.
Yeah. ABC, ABC, ABC. It's a list that contains 3 lists of size 3. Yeah. Okay. So let's continue. Consider the following schema function, and now, okay, now we're actually getting into the good part. Basically, functions are first-class citizens, meaning that they can be passed around and taken as parameters into every function. Like, there's no real difference between functions and like values, 1, 0, 10, whatever. So you can pass any function into a function. Does that make sense? Basically, functions are first-class citizens. Okay, so this guy, so we're asked to describe in words what the function returns. Increment, probably with increment n. Okay, so let's define increment n, and here the new part comes in. Like, what's this? Well, this is basically a way to declare that this function, inc, is going to return a new function, and that's the lambda, that accepts the next. So it's a function which will return another function. Okay? Now, what happens is that if you call inc with some number, what essentially that does is it creates a new function where n is replaced by the thing that you provided. So if you say inc 5, then you would get a function that will increment or add 5 to anything that function will receive. Yes. No more. Yeah, it's coming. So basically, this function will generate a new function where n is the constant. So if you provide the number into n, then the function that wait. So basically, let's try to. Okay, just look at this part. Okay, it's a function called n and takes n. Okay, that's it. So we have an argument called n in our hands. Okay, and we're gonna, and when we look at this part, we're gonna return a new function that's gonna take x as argument. Okay, but as soon as you call inc with the first argument, n, I'm going to replace it inside of the second function as a constant. You see? So if I'm going to take this, so like so. Here we have defined the function inc. If I do something like this and say, okay, inc 5, this is a procedure. So, for example, so it's basically saying, well, both the function is a Like both of these are functions. Like if I call this, it's going to give me another function back. If I call it again, let's say I'm going to call it with 5 again, it gives me 10. You see, I have to call it 2 times to actually get something out of it. Okay. Basically, the function that returns another function, where the second function is basically has a parameter that's already been taken care of with n. I'm not sure if I'm describing it correctly. I'm describing it correctly, but maybe not declaratively enough.
It's a lambda taking 2 parameters for x and
The lambda itself only takes a single parameter, but the n has already been defined when you create the lambda. So if you call inc, then you set n, and once you've called inc, the n is forever permanently what you set it to be. So for example, like after calling this guy, well, this function will always increment something by 5. You've just replaced the n here with a 5. That's just how you've done it. Like you've given a function that will always increment or always add 5 to whatever element you put into it. Okay, make sense?
yeah.
Okay.
To understand
What the x is? Well, that's this parameter. This guy. So if I do, so this guy actually is a function that will take in another parameter, and that parameter is like here, like where I'm typing right now. So this is the x parameter, and this is the n parameter. So n, x. I can't run this because, but it's x n. So it's like if I put minus or like 1, I would probably get 2. Okay. So we're asked to say what is the value of the following expression, increment -2, 3. What do you think?
1.
1. That's correct. So try it. -2 and 3. Oh. 1. Cool. So you had a question? Someone had a question. Emil, you had a question. So why the minus in -1? I'm gonna find what you're asking. Damn, that was too quick. Okay, so why the -1? I'm gonna find it. Why the -1? Oh, you're talking about this thing. Probably. I'm gonna guess this. There's like a 1 minute delay before you can actually type again, and I hear you. So, but I'm gonna describe this again. So basically, what this is doing is decrementing n by 1 every time. So if you think about it, each time you recurse or like step into the function again, like go deeper and deeper and deeper, well, you don't want to endlessly go down, you just want to go down n many times. So if you start with n and decrement it by 1 every time you recurse, well, then you're going n times into the list or n times into the recursion. So it's just like a way to actually limit your count of recursion. It's similar to the for loop of like checking. And now I'm looking at the screen, so if you all right, does this make sense? Okay, I think this makes sense. If not, I'll go over it later. Okay. Right, so where were we? We were in. Yes. Okay, so basically we're supposed to do write the lambda abstraction in lambda calculus for the function inc. So we're supposed to take this thing and describe it using lambda calculus. Okay, so bam, here we go. Okay, we're supposed to take this function and describe it in lambda calculus. So what do you think we would do? By starters, we would find this lambda function, lambda thing, so I can actually type it. Okay, so we have two parameters. We have n and we have x. Okay, so what would be the first thing we would do? Which argument is the first argument that gets called? The n. So this would be n. What's the second argument? X. Good. What is the function? What's the function that's happening inside it?
Lambda.
It's a plus, right? Plus nx. Yeah, that's true. Oh, that's it. That's it. So you can see how pure lambda calculus is. This has the same element. Like if I call this with just this with a 5, for example, well, what happens is this 5 goes into n, and what I get out is a new function that accepts only x, and 5 is hard-coded. You see, it's exactly the same, the thing I was so desperately trying to describe but failing at it. So this is what happens. Like you feed it with a parameter, that parameter gets hard-coded, and you get a new function with that parameter as hard-coded. That makes perfect sense. See? Like, bye-bye. Okay. Cool. So, the next thing, yeah, isn't this just, we're good? Can we move on?
Yeah.
Yeah, cool. Right. Now, number 6. Okay, now we have actually like dipped our toes a little bit into the functioning world, but now we're gonna take a deep dive. So push into the big lake. Here we have some text that says write the function combine such that combine f1 f2 is the composition of f1 f2, assuming both take one argument. That is, combine f1 f2 should return the function. You should return a new function, and this is important, a new function of one argument that applies f1 to the result of f2 to that argument. And this sounds overly complicated. Like, yeah. But don't be afraid. You got all the skills that you know, like you need. Alright, so we have a function. We should declare a new function. Okay. We know how to do that. Define. Okay, define, and we say combine. That's the name of the function. Combine, okay? And we should take in f1, f2. Okay. And what now? So we should return a new function. That's what was set there. basically with the description? Well, we have already something that does the same thing. Here's how we would declare a function to return, right? So why not just use that? So basically, now I'm saying, okay, combine will return a new function. Well, that's basically lambda. I'm going to return a new function. Okay?
That's what lambda does.
That's what lambda does. It's just saying, I'm going to create this function. Like this block, like this parenthesis is enclosing a function. Nameless function. But if you use define, then you're saying this function will have a name. The name will be combine. Okay? So lambda, nameless function. And the thing that it should accept is a single argument. Okay, so it should accept some x. And it should apply some order. It should apply f. It should apply f1 on the result of f2 running on x. Well, okay, so it should be f1. So it should be f1 running on the result of f2 on x. You're done. So this is the scary text that was before. Well, that's it. You're just applying f2 to x and the thing that came out of f2 to f1. Right? Does it make sense?
Yeah.
So this is just what the problem described. So, and your question is like, when is this even, what's going on here? And this is just like a cool way to think of, in math, you often have some functions that are like nested, if you think about it, like nested together. You plug a value into another function that computes something, then that thing gets like nested into another function in math. So it's a really nice mapping between this programming style and a function in math, really. So how would I use this? So let's check this out. Okay, here we have this. And I'm also gonna define this increment thing here, because I'm gonna use that. So we have combine and increment. Run. Now I have both. Okay, so basically, if I go back and just describe the function a little bit better. So this function, what it says, I'm going to take in two parameters. First one, both of them are going to be functions, f1 and f2. And I'm going to return a new function. This is what the lambda does. It takes in a single argument, x, and I'm going to apply this argument to f2, and the result of that to f1. And that's it. Okay, but now let's try to use it. Okay, so here we have Dr. Racket, and what we can do is we can say, okay, hey, I have this combine function, and it accepts two functions. Well, we know a function that returns a function, so just use it. Inc 5 inc 8 inc and 8. So okay, so basically now we say, okay, we have the combine function and it takes in two arguments. And first argument, okay, so if I would apply some number to this thing, it would first be incremented by 8, and then that result would be incremented by 5. Does this make sense? So what happens if I do this, like 3? What would be the result of this? So 3 plus 8 is what? 11 plus 5 is 16. So it's basically taking 3 and putting it into the first function, which is plus 8, and then taking the result of that applying it into the second function, which is +5. Make sense? So this is how you would combine functions. This is how you pass functions along. So, okay, what a cool thing. But you see that it's different mentality to actually write something in this versus like Java or C or something. C++ meaning, I mean. Okay. Okay, the next exercise. 7. Write a scheme function flatten, which accepts one function f as parameter, and the function flatten returns a function which applies f to the first two elements in a list. Okay, so we should create a function called flatten, and it should return a function that applies this f to the first elements of the list. First. Okay, so let's do this. Define, and now we have every tool that I think we've covered every tool that we need for this function. So I'm gonna ask you how we do it, the audience. so basically, let's call it what's called. Sorry, flatten, and it takes in an f. Then you're gonna do something. You're gonna say lambda, right? It's a new function. Okay, and it takes in a list, right? List, and now what? No. All right, so maar verhaal op de focus. All right, so basically, yeah, okay, we have this list, and we should assume that it has two elements, and I'm gonna take first element and the second element, and then apply f on it. So you say f on something. We're gonna apply f on something. So f is gonna be applied on car of list. This is the first element. How do we get the second element?
CDR.
So that's the rest of the list. If I say CDR, this, then we get the rest of the list, but we want the first element of the rest of the list.
So you call again.
Call again. We can actually just apply car on this. You see? That makes sense.
Yeah.
So we're going to get the rest of the list and get the first element of that. So this is it. This basically flattens the list by taking the first two elements and applying f on it. Okay. And the next thing is, okay, so let's check it out. Bam. Wait, I still need, I'm always losing count of my parentheses. And flatten. So let's try it out. Flatten, and let's use minus. No, plus. Let's use flatten, and I'm gonna. Okay, let's check what this returns. And you can see it returns a. It returns a plus. Oh, sorry, a procedure. So it's basically a function. So that's good. That's what we wanted. We want to return a function. Now let's apply this function. And that's just calling it in the first element, having the first block this, and saying I'm going to flatten this list. A, B. Oh my god, everything broke. Oh yeah, of course. You can't plus A and B together. 1 and 2. Oh, Oh, different broke again. What is going on? I am doing something wrong. Oh, it's probably. Oops. Okay, and let's do it again. Flatten with multiply, and do it with this list 1 and 2. There we go. 1 times 2 is 2. Let's do plus. Great. Woo. So you can see I'm just applying this function, the plus, which is a function that takes in 2 parameters, to this list. So I can have any function that takes in 2 parameters and apply it into Flatten. So we do this, say just like divided, it divides. Okay. But if I call it again, let's like so. There you go. It's just a procedure. It's just a function, right? Make sense?
It is a built-in function.
What? Flatten? No.
No, the plus.
The plus, yeah, the plus and minus and divide is all built-in functions. It's simply just defined. Like it's probably just like this. Define plus like element 1, element 2. So yeah. Right, like so. Okay. Alright, so flatten. That's current it. So 8. The function length return. The function length returns the number, the length of the argument, which must be a list. Why doesn't it just say the length of the list? Each, for example, length of ABC is 3. Okay, using length to find the procedure shorter, which returns the shorter of 2 list arguments. Have it return the first list if they have the same length. So we can use this function called length. That's good, and we should define a function that takes in 2 lists and just returns the shorter one. Okay, so let's do this. How would you do this? Fine, and it's called shorter, and we take in what? 2 lists. List 1, list 2. Okay, now what? What would we do? And we know that there's an inbuilt function called length, which will give us the length of the lists. So how can we use it? We can just do what we have done before, use if. Well, if the length of the first list is less than the length of the second list, list 2, well, then we're in business, right? Make sense? Of course. If the length is less, then we return what? List 1. And if it's not, return list 2. And then we finish this. There you go. There's one problem with this, and let's see what that is. Not a huge problem, just a small problem. Okay, bam, and shorter. And we have this list, A, B, C, A, B. So which one is shorter? Maybe. Makes sense. Woo, got that. Maybe. Okay, what happens if I do, okay, let's call this BC and we'll call this AB. So which one should be returned according to the specification, which stated that the first element should be returned if they're equal, which is definitely not easy. Should return AB, but it returns BC, sorry. So how would we fix this? Yeah, exactly. Exactly. So this is basically it, and that's shorter. So it basically checks like if the length of the first list is less or equal to the length of the second list, I return the first list. Otherwise, I'll return the second list. Okay. Okay. So, oops. So now we have to do the last exercise of today, which is the list index, which should take the lists, take a list and the number n as an argument and return the nth element of the list. So basically, you should iterate through it and give me the nth element. Okay, how would we do this? We hinted recursion. So let's do this. Look at it. Maybe just do it like this. Okay. Define right function list index, which should take a list one. Okay, like list and a number. So this function should have called list index, so, and it should take a list and a number. Like so. Okay. And now we should return the nth item of this list. What happens if n is 0? We should just return, right?
Yes.
Okay. So shouldn't that just be a really quick base case? Like if n is equal to 0, then we should do something. We should just get the element. How would you do that? You just use car. Get the head of the list. You want the first element, and I'll just give you the first element. List. Well, we got our base case. Now we have to do the recursion. What happens? How do we do this? We're gonna have to call ourselves, right? Exactly. To actually do the recursion. List index, and we could call ourselves with what?
n-1.
N-1, that's a good thing. So it's like minus n1, that's the second argument. But what will be the first argument? Car of list. Okay. However, car only gives you the first element. CDR of the list. Right. So you should call yourself with one less element and decrement n by 1. That makes perfect sense. Like every time you recurse, you just skip ahead by 1 and decrement by 1, and once you actually got to 0, then you return the element that you are in. Okay. And note that we don't actually have to think about if you go out of bounds. Like you can assume that the list contains at least an element. So if we add this definition, I always forget one braces. Okay, so fine. Okay, so list index, let's say index number 2, and it's 0 based. So it's index number 2, and I say A, B, C, D. So what will be returned? C. Nothing. He says something bad happened. 1n minus 1. What's bad about this? I ask. Okay, this is the same. This is the same. This is the same. Code minus 1. Code cooler. Your car. This. There's nothing wrong with this. Okay, let's do it again. So, okay, I refreshed. He still says something is wrong. Oh, yep, that's totally right, because I'm calling it different in incorrect order. It should be the list and then 2. Right. So that's basically it. 5 minuter. Alright, so basically we got this working. And that was basically the last assignment, or the last thing we should do. Now, what I want you to do is try to actually do the first exercise without looking at me doing it. So please create the count, or the second exercise, sorry. Please try to create the count function in your hand right now to get your first 30. That includes the people watching. Because like, it's all good and fine to watch me program, but if you do it yourselves, you learn more. But otherwise, I think we're done. I hope this actually helped you with learning programming, learning the functional programming part of Scheme. But if you have any questions, please post them in Piazza. Or just contact me directly. That's okay. Oh wait, I'm still live recording here. So I'm just saying, I think I'm saying goodbye. No questions on the chat. I'll give you a few minutes to check it out. Getting good. Okay, I'm calling it. Thanks for today.